Hi and welcome to another tutorial video. In this tutorial video I'm going to be going through the Fetch-Decode-Execute cycle in the level of detail you need to understand for A-level computer science. Okay, so we've got these registers over here and we need to know what the role of these registers are in the Fetch-Decode-Execute cycle. So we've got the program counter, the memory address register, the memory buffer register, the current instruction register, and the status register, and they're sometimes written using these abbreviations over here. So what are the stages of the Fetch-Decode-Execute cycle then? The first stage is that the contents of the program counter are copied into the memory address register. So the program counter holds the address of the next instruction to be executed. We need to copy that into our memory address register so that we know, so that we have in our memory address register the address in memory of the instruction that we want to execute. The next stage is possibly the most complicated stage. What happens is that the address that we've got in the memory address register is sent from the memory address register along the address bus to memory. So that's the first part. Then what happens is that the instruction stored at that address in memory is sent back to the CPU via the data bus and is stored in the memory buffer register. So the instruction stored at that address in memory is sent to the CPU via the data bus. And finally, whilst this is going on, the program counter is being incremented so that it stores the address of the instruction that's going to be executed after this instruction that we're currently storing in the memory buffer register is executed. Okay, so the PC is incremented. So the next part of the Fetch-Decode-Execute cycle is that the contents of the memory buffer register is copied into the current instruction register. Then what happens in the current instruction register is that the contents of the current instruction register is decoded and then executed. Okay, so we've covered the role of the program counter, the memory address register, the memory buffer register, and the current instruction register. But what about the status register that we've got down here? Well, what the status register does is it stores the information about the state of the processor. So any information about the execution of a particular instruction is stored in the status register. And an example of this would be if an overflow error occurs in a calculation, the status register would store a particular binary bit pattern which indicates that an overflow error has occurred. Okay, so a few final points then about the decode and the execute part of the cycle. So all three stages that I've highlighted here. The first stage here, the copying of the program counter, the contents of the program counter into the memory address register. So stage one, the complex stage here of fetching the instruction from memory and incrementing the program counter, so stage 2, and the copying of the instruction from the memory buffer register into the current instruction register is so stage 3 is all part of the what at GCSE you might call the fetch part of the Fetch-Decode-Execute cycle. What we've got down here is stage 4, and this is the decode and the execute part at GCSE. And when we're decoding a instruction, so decoding, what we're doing is we're using something called the control unit to decode the instruction. So the control unit decodes the instruction. And what the control unit does is it splits the instruction into an opcode. So that's the instruction to be executed and the operand, and that's the operand is the data on which we're performing that instruction. So that's the decode part of the cycle. The instruction is decoded by the control unit, and the control unit splits the instruction into the opcode and the operand. So the execute part of the cycle then. The execute part of the cycle is, first of all, what happens is If necessary, more data is fetched to complete the execution of the instruction. So that's what happens first of all. The opcode that we split apart from the operand in the decode part of the cycle then indicates the instruction which we need to execute. The instruction is then executed by the relevant part of the processor, and then the result of that instruction being executed is stored in the accumulator. Okay, so that's just a bit more detail on the decode and the execute part of the cycle, and it's a really good idea to include that detail in your answers. Okay, so that's an overview of the fetch, decode, execute cycle and what these 5 different registers do. Hope you found this tutorial useful, and thanks for watching.